Okay, this is Ryan Womack, Data Librarian at Rutgers University Libraries. We're back with part 5 of data visualization in R. And in this segment, we're going to talk about ggplot2 and the grammar of graphics. So let's jump in and think about what's going on here. This is really our final historical figure along the way, not very historical because the grammar of graphics was published in 2005 by Leland Wilkinson. And in this case, we're looking at grammar as rules for art and science, right? This is an abstract definition of grammar. And that can apply to not only linguistic grammar, but other kinds of rules. And so what Wilkinson did was think about what rules would be appropriate for graphics and visualization. And if you look at that book, it's quite abstract. It is not a very hands-on type of book, but it talks about many different categories that the things that build up a data visualization belong to. So there's the data itself, and that would include things like basic manipulation of the data, such as weighting the data or resampling the data, things like that. Variables that are computed on top of the data, such as rankings or transformations. And I won't go through all these, but there are many different things that can be done. Changing the scales, computing formal statistics based on the data, and then we think about how the data looks itself, the geometric technique used to plot the data, the different aesthetic characteristics of color and size, and all these things. So if you read his book, again, you can go into more detail. We're just alluding to that because this whole technique of the grammar of graphics was used as a basis by Hadley Wickham in the development of his very popular R package, ggplot2. So again, a reason that we're focusing on this package is partly its relationship to this concept of grammar, but also because it is a very popular and powerful package in R that can do a lot of things for you. Many different graphic types, but not 3D data, which is going to come later in another segment. So this slide has some links, ways to get help with ggplot2. We're again more focused on just showing you some of those capabilities and thinking about how this will work in a data visualization context rather than the fine points of grammar. But you can work from the examples in the code file and build up your knowledge there. So we are going to continue to work with the diamonds data set that we've been looking at in the previous segments. If you're just jumping in at this video without doing the prior ones, realize that you do need to go back in the code to section 2.1 to load the diamonds data with these commands, library ggplot2 and data diamonds. Okay, so all the commands we're going to look at in this particular video are in section 3, and we're looking at the way ggplot works. So let's just start out by reproducing our standard scatter plot of the price versus carat of diamonds. Now ggplot2 does a few other things with the data. It uses this gray background with sort of a subtle cross-hatching, and that is a recommended technique that allows you to show the grid that the data is based on, so we can really see exactly where the points lie, but to show it in a very subtle way that does not interfere with the perception of the points themselves. So that's the default, but that can be turned off, and we're going to see that later. Okay, so how do these ggplot commands work? Well, they have their own grammar, as we've been talking about. So almost all ggplot commands just begin with the command ggplot. We start out the ggplot system. We let R know that we're working with the diamonds data set, and then we have this AES characteristic. So AES is the abbreviation for aesthetics in the grammar of graphics, but it's a little bit more than aesthetics because it kind of signals the main data that we want to focus on. It's the aesthetics of the points that deal with, in this case, carat and price that we are worried about. Apply the aesthetics to your actual data that you want to plot. And then, unlike other R commands that are self-contained, we always have to have at least one plus with the ggplot2 command to add at least some kind of display. So by saying geom point, we are instructing ggplot2 to use the geometry, use the form of display of graphing the points, or what is in this case really a scatter plot. And so that's a starting point for a standard ggplot command. Just like in other cases, we can compute some data inside the graphing command. Here we use the x times y times z to see the relationship between the volume of the square or cube that the diamond would be contained in versus the weight of the diamond, the carat. And we can also continue to add other elements to the graph by using the plus. So in contrast to lattice, where there was a simple vertical bar or pipe that you just throw that in and then throw in the variable that you want to class by, in ggplot2 it's a separate element. It is the facet grid element. So we do plus facet grid, and then in this case we are faceting by clarity. So the syntax looks like that. The default is a bit different in that it just creates 8 separate columns for the 8 separate clarity ratings. And that's perhaps not the best perspective on this data, since it just generates these very steep lines, but we're not going to tweak this particular graph at this point. But that's the first illustration that we've seen of multiple components of the graph, multiple pluses. Now, you may find this syntax a little funny the first time you encounter it, but we're going to see in a bit some of the benefits or some of the reasons that this can be very useful. All right, and again, if we want to start tweaking this data, we can do things like ask for the points to be color-coded by applying a separate aesthetic to the points under the geom point. So we have one aesthetics command that's sort of the base variables, and we have under geom point aesthetics color equals cut. So that's telling the scatterplot method to color the points by the cut of the diamond. And once you get used to that syntax, it's extremely logical, and the default output that comes out of most of the ggplot2 functions is very nice. So here we can see our colored scatter plot. And if we want to tweak the graph to have titles and labels and everything under our control, we can do that as well. It's just a matter of adding further options. So if you look at this last line in 3.1, you'll see x limit for the limit on the x-axis. We can adjust the color of the points, the printing character of the points, that's PCH3. Add labels, so that's all under this labs segment, kind of logically grouping the labels of the graph into one piece. And that makes it easy to identify, what's what. Although the commands can get long, they're very logical. All right, so we've reproduced our earlier work in lattice. We're going to keep going, do a few more examples like that, just so you have some comparisons. You can do things like a histogram. That's just geom histogram. So this is a histogram of the depth of the diamonds. The depth is a measure of the shape, the proportion of the shape of the diamond. Let me just leave it at that. We can do things like adjust these aesthetics as well by filling the columns of the histogram according to the characteristics of the data. So this example fills the columns by the actual count level. and gives us a shaded histogram with some meaning attached to it. And you can see the scale automatically is added on the right hand side. So that's again a nice feature. And again, the more you dig into ggplot, you'll find that there's a lot of ways to customize it and build those graphs exactly the way you'd like. I do recommend highly the website with the help docs, because that is the most complete place to get a reference. There is also a book by Hadley Wickham in the Springer Use R series that's listed in the bibliography that you can look up and get more information there. Okay, but let's keep moving quickly through these standard graphs. We'll look at section 3.3, a bar chart. Now the base bar chart, kind of plain, geom bar, and the position is stack. So there are really two positions for the geom bar. One is stack, which is vertical, and dodge, which is horizontal. If we want to plot other things, we can just change the variable. And if we want to plot some things side by side, like we did in Lattice, the command for that looks something like this. Last line in 3.3, we have clarity as our basic thing that we're plotting. So these are the 8 clarity ratings. Each panel here has the 8 clarity ratings represented. But we're going to facet it by cut. So the 5 cuts form the 5 different panels of bars, and then geom bar sort of floats as a separate command out on the right. Okay, those are sort of the basics, and since we're looking at extras in visualization a little bit more in this particular workshop series, in section 3.4 we're going to look at the use of another package, R Color Brewer, which enables you to easily apply these nice color schemes to your graph. So this is a bland grayish, not even black and white, but a grayish graph. We want to liven it up a bit, and we are going to use the Color Brewer to specify different elements. So the first line in 3.4, actually we're not using Color Brewer yet, we're just starting to change some of the colors of the picture. So we can adjust the theme, and we can set the colors of specific elements there, such as the fill and the background color. So we do that, and now we've got some vibrant pink and purple going on. We've also got a faint green outline of the boxes. Just, you know, a random example of something you could do. We can also clean up the graph. I mentioned earlier that you could remove the gridded background. So if you want to do that, the example is here. That's by setting the panel background in this fashion so that it's just a pure white background. We've removed the influence of those white grid lines. And in the third line, this is where we actually use the Color Brewer. So we are going to fill our bars by the clarity factor, and we use this other command. Again, I'm skimming over the sort of nature of these commands just because the intention here is really to illustrate the possibilities. And if you want to learn and master the actual R code, the thing to do is go to the documentation, start Googling, look for examples, and work that way. And you can build off some of these examples in this code, but this is not meant to be comprehensive. But so essentially what we're doing here by using the Scale Fill Brewer, that's a special command that uses the R Color Brewer palettes of shading, and there are some standard groups. So this is a shades of red from light to very dark, and that lets us distinguish between those clarity levels based on that. And you can simply change the palettes, and if you read about the R Color Brewer our color Brewer documentation, you'll see there's several different things you can do. You can also program your own custom palette that you can reuse. It's actually also quite powerful, but there's standard selections like reds, blues, and greens, and multicolor shadings that you can just apply, and they look pretty good, and you can work with those. So this section is theme tweaks, right? Another thing that I've got in the commented code, I'm not actually going to run it with this example, but in some contexts you can use the option Scale Color Manual, and you can set your own range of colors simply by typing in the names of the colors you want to use. That's another possibility. And so let me leave those tweaks aside there, and let's try to again reproduce some of the things we've been doing in Lattice by looking at how we plot regression lines, and also this is an example of how we plot multiple concepts on the same graph in ggplot. And it turns out this is a pretty simple thing to do. We always start with that base setting of which variables we're dealing with. Then we add a point geometry to ask ggplot to do a scatter plot. And we can simply ask for another method to be plotted. So here the method is geom_smooth for a smooth line. And we have a few different options of how to draw that line, but we're going to ask for a linear regression to be run and plotted on the graph. Now in this case, the predicted value of the very high weight diamonds is very high, and it sort of shoots off the scale compared to the actual data. So if you wanted to adjust for that, you could set a limit on the y-axis and fix the plot from a visual point of view like that. But this is the standard output that you would get. There are many methods. If you look at the ggplot documentation page, you will see that there are many different geometries, each of which has its own modifications and customizations, and we'll be seeing a few more of those in the upcoming sections of this series. But right now we're going to use one more, which is the stat_smooth command. So here this image just has a standard linear regression, but if we wanted to do a smoothed regression to provide a better fitting curve, we can do that with stat_smooth. Stat_smooth, like many other things in R, also has its own options if we wanted to really modify the way that this line is computed. There's a lot of power to do that, but in this case what I've done is I've used a different data set just because the smoothing effect is a lot more visible. This is a data set of motor car information with miles per gallon versus the displacement or the size of the engine. That we're going to come back to this data set later in the series as well, but right now I'm just loading that data set empty cars, plotting miles per gallon versus the size of the engine, asking it to plot the points, and doing a stat_smooth. So this blue line is the best fit to the data, and the gray shaded part is actually the confidence interval around that smooth line, so that the method predicts that most of the data would fall in the gray area. Actually, we have a small data set. We've got probably more outliers there than we'd like, so maybe the fit is not as nice as is predicted. But it at least gives us a nice sense of the pattern when we do something like this. And again, in the note to the code, if you want to customize the confidence interval, you have to do some computation on the side and then insert it back in. There is a way to do that. Just alluding to those things for those of you who may have questions about things you think you're going to need a little bit later down the road. All right, so now we come to the crux of the matter in section 3.6. I've been talking about the grammar of graphics and saying that this sounds important. Well, okay, this is the example that really shows you how it can be used and why it is an effective way to think about things. Like other R objects, we can save these commands into sort of shortcuts. And so what I'm doing in section 3.6 is taking a few pieces that relate to the data itself and storing them as something called my data. This is not plotting anything, it's just saving this object called my data into the workspace. There it is. I am going to save a series of settings that simply relate to my preferred theme, and I'm going to call it my theme. So here I've got the pieces of a ggplot command that refer to the theme. And then I can have a separate part that will be my preferred chart method. So I want to do a bar chart. I want to have these specific colors used for the elements of the bar chart, and I can save that. And once I have all those things saved, I can produce a graph just by stringing those together. Remember, everything in ggplot is separated by a plus, so if I do my data plus my theme plus my chart, I can get my customized graph that looks like this. Okay, that looks great, but think about it for a second. If I wanted to apply a different look to this particular graph, let's say I had 4 or 5 favorite themes that I wanted to use. Well, I could just run this same command again, but with my theme 1 and my theme 2 and my theme 3, and very, very quickly make those changes. I could even automate that and have a whole series of things generated. I could get my exact preferred look applied to any data set by running these commands on my data 2, my data 3, my data 4. And the same goes for different charts or visualizations. If I don't like a bar chart and I want to change it to a scatter plot, I can do that very quickly and surgically almost by slicing out this separate piece that only deals with the geometry of the graph and replacing it with something else. So when you have large scale data needs that you have to plot many different variables, many different looks and themes, or at least enable those options, the more of those combinations you have to deal with, the more this approach makes sense, and the more you may want to think about using a program to automate the generation of the data, which this grammar really starts to shine when you do that kind of work. So I hope that gives you a sense of what the grammar of graphics and what ggplot2 is all about. Just to conclude this segment, I have a little bit of code that will show you, if you remember from our earlier workshop video, the famous, highly touted graph of Napoleon's march to Moscow and back. Well, just for fun, we're going to do that in ggplot2. This code in section 3.7 will read a little bit of data from my website, load some little helpers for maps, and then we can actually plot it. Now, it doesn't look super polished. The line segments connect in a slightly rough manner, but it is actually the same data and the same points. And we can also generate a separate panel for the temperature, and with a few more steps, you could paste those two images together and smooth them out a bit and make something more polished. But think of this as tribute to Menard and maybe a small example of how flexible ggplot2 really is, and it can produce a wide variety of different kinds of images. So our next segment is going to deal with a whole area that I call a miscellany of visualizations, and we are going to take a whirlwind tour of many different kinds of imagery, graphical tools that you can apply to your data sets, and talk about when you might want to use those. So that's what's coming up in the next part. Stay tuned for that. See you in a bit.